rate just went down. Alright. We good? We got the essential question written?
No.
Alright. There's the first definition. Write that one down. I know we started trig the other day, and we probably should have had that one first, but it's here. Well, we started trig from the Algebra 2 book. This is the first day we see trig in the pre-calculus book, so. On the quiz, it should be, huh? But we don't have quiz. So trigonometry is the Greek word for measurement of triangles, is what it officially means. Probably not. Alright, we got it? Okay, I'm going to give you about 3 minutes to write. Fill in the blanks. I know, write tiny. I know there's not enough space. Joe, write. Take the headphones out, please. Give me about 1 more minute to write. I know today's a lot of writing. First day we always start. There's always a lot of vocabulary. It will get better. Yeah. The rest of it's easy stuff today. It's just there's a lot of vocab. To understand what things are, but I don't, ask specifically what's the terminal side, what's the vertex. You need to understand it. Okay, so some of this stuff and some of the words that are in there are things that you did learn when you were in geometry. And I know some of us, that was last year, some of us it was 2 years ago, okay? So, but we've all seen a lot of these words before. So the way we approach the word bit different than what you did in geometry. In geometry, it was just two rays, okay? In here, we typically take the array that is rotate, and we rotate one of the sides, and that gives us what the angle is. This is the endpoint of the ray. Remember, a ray is basically a line that has an endpoint, okay? The initial side of the angle is the starting position of the rotated ray, and notice I've got two pictures there. One of them is kind of generic. One of them we put on the XY axis. When we go into the XY axis, we typically have the initial side on the positive X axis, okay? And all of our work, for the most part, is going to be done on the coordinate plane. The terminal side is the position after we rotate it. So if we take that initial side and we rotate it a little bit, that's what we call the terminal side. Okay, so that's where the ray or the angle ends. The vertex is that endpoint where both the angles come together. And this one here, which is the one that is in standard position, okay, you might want to write that in there, that's the standard position example. That vertex is actually at the origin, all right? And we know that the angle's in standard position because the vertex is at the origin and the initial side is on the positive x-axis. So that is what a typical standard position angle looks like, okay? All right, go ahead and write those couple of words in there. Okay, so back in geometry, all we could have were positive angles, right? Couldn't do anything negative. Well, in this class in trigonometry, we can have angles that are positive and negative, and it's a directional thing. It depends on which direction you're going, okay? So if we are going in the counterclockwise direction, that means our angle is coming out positive. If we're going in the clockwise direction, that means we're going backwards through the around the origin. That means we get a negative angle. Okay, so if you go up first, that's positive. If we go down first, if our arrow points down first, that means we have a negative angle. All right, there's the next one, coterminal. Alright, so coterminal means that the angle has the same initial side and the same terminal side. That doesn't necessarily mean that the angle has the same, well, it sort of has the same measure. Okay, so here's what can happen in trigonometry. First of all, does everybody know what that means? That little symbol right there? That's the Greek letter alpha. Okay, it looks like a little fish. The B with the tail on the end of it, that's the Greek letter beta. Okay, so when we run out of thetas, we do alphas and betas. So they'll sometimes put those in there. All right, we tend to see a lot of the Greek letters with trigonometry. All right, so if I was going to measure an angle in the positive direction, it would land, they're saying, in the third quadrant there. But I could have another angle going in the negative direction, and it would be what we call coterminal with that. Remember that prefix co means the same. You had lines or points that were collinear. You had points that were coplanar. They were in the same plane, or they were on the same line. Okay, when we were in geometry. Another thing that can happen, okay, is not only can I just measure an angle, but I can loop around that circle and go more than 360 degrees to measure an angle. And so that's another way to get an angle that is coterminal. Okay. All right. I know you don't have central angle. Okay, so don't worry about that, but fill in the blanks on this piece right here. I think you have that piece right there. Central angle somehow did not get put in the notes. It's not a huge deal. You don't need to write it, no. It's not a huge deal that it's not there. So the measure of an angle is the amount of rotation required to rotate one side, called the initial side, to the other side, called the terminal side. So if we went back and we looked at this picture here, the measure of the angle is the distance between the initial side, or the rotation distance between the initial side and the terminal side there. That's how we measure an angle. And we're going to have the two different types of measurements. We're going to have degrees and what we call radians here. Okay, so there's the next one. It says 1 blank, and it says it should be radian. So fill in those blanks really quick. Okay, so this new measure that we have, I didn't go over central angle. I kind of skipped over it, didn't I? Yeah. All right, so we're gonna talk about a central angle. You don't need to worry about writing it down. Basically, a central angle in a circle is an angle whose vertex is on the center. So that picture that you have, this picture is showing a central angle. Okay. You had central angles in geometry. You talked about them in circles. You also had a central angle when you were doing regular polygons. Okay. So. It's basically the radian is the measure of the central angle that intercepts an arc S equal in length to the radius. So what they're saying is that this length right here, if I were to take a string and measure that length, and I lay that string on this arc, those distances would be the same thing. Okay, that's what they're saying a radian is. All right, and we're going to spend this week, part of this week, discussing and exploring radians a little bit. Okay. Algebraically, that means that our angle measure is this S value, the length of the arc, divided by the radius, whatever the radius is, where it's measured in specifically radians. Okay. All right. In a circle. Okay. So go ahead. I want you to write that 2 pi r down. 2 pi r. Fill it in the blank. Flip to the next page, dude. There you go. Okay, so if you think about the talking about the outside of the circle, we call that perimeter, but in a circle, what do we call that? Yes, it's the circumference. Isn't that the formula for circumference right there? Okay. So if I was to walk around the edge of the circle, 1 full revolution around the circle would be 2 pi r. Okay? What if my radius length, what if my r value is 1? What's 1 full revolution around the circle then? 2 pi, right? So I know that if I'm going to call my radius 1, I know that 1 full revolution around my circle is 2 pi, okay? So if I'm going to put this into radians, okay, and I'm going to just assume, I'm just going to go with my r being 1, okay, because that's how it is for the whole rest of the unit, all right? So I'm going to take that 2 pi and I'm going to multiply by 1/2, or I'm going to divide by 2. What's half of a revolution? How much? Pi. Half a revolution is pi radians. So right here would be pi. Think about that. Look at this funky measure they have there. What's the decimal point for pi? 3.14. Isn't it? Look at, if they say 3 radians is here, is that about maybe 0.14 radians? Yeah. Okay, so a half a revolution around the circle is 3.14. All right, quarter revolution. So I'm going to take that full revolution, which is 2 pi, and I'm going to divide it by 4. What's a quarter of a revolution? Pi over 2, or 1/2 pi. We typically say pi over 2, and that's going to be right here, isn't it? A quarter of a revolution. We're going to get a little bit more specific on those in a minute. A sixth of a revolution. All right, I'm going to take that 2 pi and divide it by 6. What does that reduce to? Pi over 3. And it's not, I'm not going to try to label it on this circle. We'll do a pi over 3 circle here in a minute. Okay? the next little box has some common angles that we typically have in a circle, okay? And these are the ones we usually work with. We have things that we divide by 6, okay, so we've got pi over 6's, and then we've got pi over 4's, and then we've got pi over 3's, pi over 2's, which is a quarter, pi's, which is a half, and then the whole revolution around is 2 pi, okay? I'm going to do 2 more things, then I'm going to kind of come back to that concept, all right? All I want you to deal with on this is I just want you to remember the names of the quadrants, okay? We're going to do that in one other thing. So the names of my quadrants, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So that's how we name the quadrants. If you forget, it makes the letter C. So you start with the positive, make the letter C to follow and number it all the way around. And we typically number them with Roman numerals, all right? How many degrees is this right here at where the y is? 90, right? How many degrees would this one be then? 180. Another 90 would be what? 270, and then another 90 would be 360. So around 1 full revolution in degrees, which is what our brain has worked into this point, right? Is 360. If I was going to switch this to radians, we talked already here a minute ago that that's pi over 2. What did we say 180 is? Pi. I'm going to give you this one. We didn't talk about this one. This one is 3 pi over 2. Okay? And how much was 1 full revolution? 2 pi. But this is also 0. Okay? So it's 0 and it's also 2 pi. So when we go back to the notion of what's acute and what's obtuse, all right? Acute, we would say, is between, when we thought about acute in geometry, an acute angle is between what degrees and what degrees? Yeah, between 0 and 90. So it's 0, it's basically point whatever to 89.99999, right? In radian world, we would say it's between 0 and pi over 2. I'm not going to do any examples, but they're going to probably ask you in the book what if it's an acute or an obtuse. Okay, so you need to be able to answer that. An obtuse was between what and what? Do you remember? 90 and 180. Good. So in radian world, that means we're between pi over 2 and pi. Okay. All right. Now we're going to go look at your little circles. Okay. Before we get too far, I want you to glue them down to your notebook page. So your circles that we just cut out a few minutes ago. Pop this up there. Okay. So there's what my notebook page should look like. I want you to go ahead and glue the circles in. Leave yourself some space in between them to do some writing around them. Okay, we're going to write small. Notice I glued them in a specific order. I glued the one that looked like it was in 8s at the top. And notice there's a little arrow, right? Try to glue the arrows up and down. I zoomed in on that a little bit. Oh, other way, zoom. All right. There are little arrows. Glue the arrows going up and down. Okay, and then the next one I glued was the one that had just one X in the middle, and glue the X going up and down. And then I glued the other one with the most lines at the bottom. Okay, and again, try to find the arrows and glue the arrows so that they're pointing up and down. Huh? It's close enough. It's close enough for our purposes right now. About 30 more seconds to glue. We're going to see how far, because we haven't even hit an example yet. Okay, here we go. So I'm going to hop back over here to this. We're We're going to talk about these little circles, okay? So I'm going to start with this one. This is my pi over 4 circle. All right, and all we're going to do right now is learn how to count, okay? I know that when I start here, I'm starting at 0, all right? And we've already learned that over here is pi, right? Okay, so I'm going to count. And I said that this is the pi over 4 circle, so I'm going to count my pi over 4. So I'm going to say that that's pi over 4. My next mark is going to be 2 pi over 4. What's my next mark going to be? 3 pi over 4. Isn't pi the same as 4 pi over 4? Doesn't that reduce to pi? Okay, and then what's my next mark? 5 pi over 4. My next mark is 6 pi over 4, and my next mark is 7 pi over 4, and my final mark would be 8 pi over 4, which is the same as 2 pi. Okay, could I keep counting? Couldn't this be 9 pi over 4, and 10 pi over 4, and 11 pi over 4, and 12 pi over 4? I could keep counting around the circle. Could I go backwards? This would be negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4. So depending upon the direction, I could count. I just have to kind of remember that my pi over 4, it kind of quarters the top half, right? It splits it into 4. All right? Okay, this one here is going to be my pi over 3 circle, starting at 0. And it's not split perfectly into thirds, and you kind of have to ignore this axis right here. That doesn't help my third situation, okay? But I left it in there because it's an axis. So, my first part is pi over 3. My second one would be 2 pi over 3, and at pi over 3, or 3 pi over 3, I should be on the axis, right? Because that reduces to pi. Then I get 4 pi over 3, 5 pi over 3, and 6 pi over 3. What's wrong? Ignore the center line on that one. Huh? The top half is in thirds. 1, 2, 3, because this is the 3/3, right? And then the bottom half is in thirds. Okay, because remember, your whole revolution is 2. Alright, so you need to have 2 sets of thirds to get all the way around. Okay? Alright. So looking at this one on the bottom, look at the top half. What is it split into? Not quite perfectly, but what is it split into? It's split into sixths, right? So I should end up with 6 pi over 6 when I get halfway. Alright, so this is at 0. My first one would be pi over 6. What's my next one going to be? 2 pi over 6. You're going to include the axis this time. 3 pi over 6. 4 pi over 6, 5 pi over 6, 6 pi over 6, right? And then I keep going. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and finally, and you know you've done it right because you end up with 2 pi, right? It reduces to 2 pi. And again, I could count more, couldn't I? This would be 13 pi over 6, 14 pi over 6, 15 pi over 6, and I could count backwards. I could go negative pi over 6, negative 2 pi over 6, negative 3 pi over 6, negative 4 pi over 6. So all I have to do is count, all right? Okay, so from there, we're going to determine which quadrant each angle lies in, okay? So, everybody got it labeled? I'm going to give you about 20 seconds and then we're going to move on because we haven't gotten to an example yet and I'd like to be able to at least get you part of a homework assignment.
Okay.
You'll just have double tomorrow.
Okay, let's do it tomorrow.
Okay. Okay, so we're going to determine which quadrant each angle lies in. Alright, so remember we had the quadrant names over here? We did that, 1, 2, 3, 4. You can kind of almost look in here, right? There's quadrant 1, quadrant 2, quadrant 3, quadrant 4. But you're gonna have to use our little counting method to, you could just look back, but at some point you're gonna have to be able to count it off, okay? So if it says divide by 4, that means the top has to be little circles as reference. Okay? Alright, next one's pi over 3's, right? So what does that mean I need to split the top half into? 3. So I'm going to do this, right? I'm going to kind of do that, and I'm going to ignore that center line, kind of, right? I'm going to highlight it so I don't count it. Okay, so don't count the highlight. Has to be there, but... Alright, so I'm going to go. Let's see. 1, 2, 3, 4, 5 pi over 3 would land there. So what quadrant am I in? 4. All I did was count it off. Okay? Ooh, the next one's weird, isn't it? Did we have an over 12? We didn't, did we? Okay? So I need to kind of figure out where would over 12 be. Okay, so here's the strategy I'm going to use on this one. Okay? Well, could we split it into 12s? How many would be inside of each one of those? 6. So let's see. 1, 2, 3, 4, 5, 6 would be that last one, right? 1, 2, 3, 4, 5, 6. Where quadrant would I land in? I'm going to end up landing in 3 for -7, right? Think about this, though, too. If I were going this way and I'm in 12ths, I shouldn't go past that, should I? Because it's 12 pi over 12, so we know it have to be at least underneath there somewhere. Okay? Alright, the next two are weird. Are there any pi's? No. Yes. Okay, look at that picture right there. Do you see where the radians are falling? So if I'm looking at 3, and I want you to go ahead and change it to a +3, not a -3. +3 lands in which quadrant? It lands in 2, right? It's 3 and a little bit more. Okay, so that next one lands in 2. Let me get back to that, because I said to switch it to +3. Okay, so that's going to land in quadrant 2. Alright, what about 4.25? If I went back to that one again. So 4 and a little bit more is going to land in quadrant what? 3. So it's quadrant 3 for that last one. And I know a lot of them landed in 3 and 4, and that's okay. It's not always going to happen that way. Alright, let's keep going. We're now going to try to sketch each angle in standard position. All I want you to do is try to land in the right quadrant. Okay, I'm going to count it off again. So 6 means I divide the top half into how many? 6. Okay, so let's see. And I get to use the center line on the 6. The only one I don't use the center line on is the 3. So that means I'm going to go into about thirds on each side, right? So let's see. 1, 2, 3, 4, 5, 6. Where do I actually want to draw my line? Don't I want to go into quadrant 3?
Yeah.
So the angle that I would actually draw, I probably wouldn't make all those marks in there. In fact, I'm going to erase them. Okay? It's kind of trying to show you that you can kind of sketch it out. You might want to use two different colors. I would draw that ray. This ray should, in theory, be there, right? I label it with, I draw an arc on it, and then I label it with the angle measure 7 pi over 6. Okay? If you want, draw them dashed lines, and then draw your final in a solid line. That's a way to distinguish, kind of, so you can help yourself measure out a little bit. Alright, for the 3, I need to split the top half into what? Thirds. Okay, so I kind of would have something there. Let me try to do the dashed line thing, and something here. Okay, I'm going to switch to a different color. So I'm going to count out 2/3, right? Here's 1/3 right up to there, right? There would be 2/3. So I'm actually going to draw my ray right in here. Draw my arc for my angle measure, and 2 pi over 3. Okay. Again, what am I going to split it into? I'm going to split each half into thirds. So actually, I'm going to go something kind of like that. And I'm just using dashed lines. Do I want to go in the clockwise direction or the counterclockwise direction? You want to go clockwise, because what's the indicator? It's negative, so I got to count out 4, and remember I'm ignoring that center line. So 1, 2, this one's part of it, 3, 4 would be right there. And remember, the arc is going to go go down first, because we were -4 pi over 3. The center line only on the thirds. Okay, and the horizontal center line is always part of it. one that we ignore it on is the thirds. Okay, on the 2, can I just go back to that funny circle that we had earlier? This one? Draw it just a little bit past 90 degrees. That's all you're going to do on that one is follow that picture. Okay? So here it is, a little past 90 degrees is my 2 radians, which we can abbreviate with RAD. Okay, so that was my sketching. Let's see what else I got here. Alright, complement, supplement. Let's see if we can get through that. Oh, you know what? You need to squish example 3 into the column. We need that one. So write down this. I didn't get typed in. Sorry. So example 3, EX3, determine 2 coterminal angles. You don't need any more instructions than that, and write A, B, and C. So ignore this part here. Okay. We're going to do one positive and one negative, but you don't need to necessarily write that out. Either and somewhere in the left-hand column. You can do it on page 132 in the left-hand column. That's fine. Okay. And we'll try to get through this one, and then we'll stop. And I'm going to still give you the same homework assignment. I probably won't do questions until Thursday. How's that? Okay. So we'll still split it into the same split I'm going to split, but we'll finish this one tomorrow. Most of the rest of it after here is degrees, so which isn't a new thing. All right. So we had talked about 1 full revolution around that circle is how much? 2 pi, right? 1 full revolution is 2 pi. So the way that I'm going to come up with a coterminal angle, one that's positive and one that's negative, so one that lands on the top, is I'm going to either add or subtract 2 pi from whatever I have. Okay. Please help me do this, and hopefully you can get these fractions right. If I'm going to add 2 pi, what's a smarter 2 pi to write down? Well, right now it is 2 pi over 1. I want to add it to something that has a 6 on the bottom. There we go. 12 pi over 6 is a smarter 2 pi, right? So when I add 12 pi over 6 to 1 pi over 6, what do I get? So that is an angle that is coterminal to pi over 6. Okay? Alright, it said I also needed a negative coterminal, so I could subtract that. Possibly get a negative coterminal. So what do I get when I subtract? Negative 11 pi over 6. Those are all names kind of for the same terminal side. Okay? Alright, let's do an over 4. So, if I've got 9 pi over 4 I want to start with, if I'm going to add 2 pi to it, what's the smart 2 pi to add? 8 pi over 4. Good. Alright, so what's 9 pi plus 8 pi? 17 pi over 4 is a good positive coterminal angle. Alright, how do you think I should get a negative coterminal angle? No. Okay, so we could. You're right. I'm going to start by just subtracting. Okay? So if I subtract 8 pi over 4, what do I get? Could I use that as my positive one? Sure, it's coterminal. I'm not done though, right? I'm going to have to go again. So I'm going to subtract another 8 pi over 4 off my answer, and what do I end up with? Now, if I had recognized that I needed to double it to get negative, could I have done that? Sure, okay? But make sure you're doing a full double, because you need to make sure you're going around that circle a full revolution, okay? Alright, let's try this one. I'm starting negative. Let's go positive first, see if we can get it to knock back to the positive. We're in pi over 3s, so what's my smart pi over 2? 6 pi over 3, good. Oh, we ran out of time. 11 pi over 3. Let me get you the homework written down, okay? Sorry. You guys can start putting calculators away while I'm... There's the assignment. It should be 12. Okay?